biology classes. All right, guys, so welcome back to another fun day of biology. So, of course, you already know, let's get into our lesson. So, our lesson for today is about carbon and nitrogen cycles. It is Unit 1, Day 6. We have 8 days in Unit 1 before our test, so the test is coming up, guys, so make sure that we are studying and reviewing information on our own. I can only give you the information and tell you to do certain things, but you have to take the time and the effort to study on your own, okay? Biology is one of those courses you have to do work outside of just regular class time. So, first of all, how are you? How is virtual learning going? So if you say it's good, go ahead and give me an A. If it's meh, or if you think it's not good, you can't see the not good, okay? I just want you to know, like, how is it going? How do you feel in my class? How do you feel in your other classes? Go ahead and just tell me everything. So today's learning outcomes are 1, what is the importance of the carbon cycle? 2, what is the importance of the nitrogen cycle? And 3, what happens if we disrupt, if we mess up these cycles? So first things first, what exactly is a cycle? So a cycle is something that repeats over and over and over again. So an example of something like that would be the grading cycles. So every 6 weeks, you start new. It repeats over and over and over again until the end of the school year. There also are no losses. So matter and energy are never created nor destroyed. They're only ever transformed. And then recycling, again, things to be used over and over again. So what goes in comes out and goes back in again. It's a cycle. It's a circle. So we learned energy flows through an ecosystem through eating of organisms, right? And also we have other parts of energy that are released as heat and waste. So again, that's that 10% rule. 10% of energy from one trophic level to the next, while 90% of it is lost as heat and waste. Now today we're going to be talking more so about a chemical element, an actual physical element, an atom. These things are going to be recycled and used over and over again. So example, water is recycled, right? You learned about the water cycle, about how it gets evaporated and then it comes down as rain or snow, right? You learned about that. We're going to learn about something. We're going to learn about the carbon cycle and the nitrogen cycle, but they are very, very, very similar to the water cycle, okay? So again, carbon is an essential element in all living organisms. So what exactly is carbon? What is carbon? Carbon is a building block of biomolecules. So bio means what? Bio means living, exactly. So it's a building block of living molecules. So all living molecules have to have carbon in them. Carbon is also found in the air that we breathe out, and it's also found in the oceans that we swim in, right? Carbon is everywhere on Earth. It also is found in different forms. So, of course, the most common one that you probably already know is CO2, carbon dioxide, right? That's the air that we breathe out. That's carbon dioxide. You may also know about fossil fuels. Fossil fuels are like coal, gas, things like that. These are things that are found in the ground, and people dig them up and then put them in cars, right? Fossil fuels. You maybe don't know about this, but you will by the end of the school year, about carbon chains. So in your DNA and in your proteins, you have repeating carbons that are linked together like a chain that you wear around your neck, how it links together, right? There's carbon chains in DNA, protein, sugars, all of that. Last but not least, another form of carbon that we'll talk about is sedimentary rock. So old rocks that have trapped carbon inside of them. Life wouldn't be possible without you, carbon. We love carbon. Carbon is literally why you are alive today. Carbon. So how important is important, right? So there's things in your body that are called cell membranes. They surround every single cell, all billion plus cells that you have in your body. Sugars, so all the food that you eat has some sort of sugar in it. And DNA, so what makes you, you. DNA is like the recipe to making another you, or making another plant, making another bacteria, DNA, right? So carbon atoms alone make up 18% of your body. That is a very big number, a big amount of your atoms in your body, right? What makes up your physical body are carbon. So carbon is extremely important to life. It's also important for humans, particularly because we use carbon, like fossil fuels and natural gas, to power our cars, houses, and factories. So carbon, there are three things that can happen to carbon. It can be removed from the air, so pulled away from the air and put into something else. It can be pushed out of something and into the air, or it can be long-term stored inside of a rock or a volcano. So again, it could be removed from the air, it could be put back into the air, or it can be stored for a long time. That's what we have. This thing's called carbon sources and carbon sinks. So a carbon source is going to be an output, right? It's going to release carbon into the atmosphere. So carbon source puts carbon out. So example of that, burning fossil fuels and gas, right? That takes carbon that was in a liquid form, it puts it into the atmosphere as the exhaust that comes out of trucks and cars. Well, we have things that are called carbon sinks. Think about it. Sinking from the air into something, it sinks, it's removing carbon from the atmosphere. So a good example of that you should absolutely positively know is that they're freezing cold oceans. Very cold oceans take a lot of carbon out of the air. All right, so autotrophs and heterotrophs have different roles with carbon. So autotrophs' role is to do photosynthesis, right? We talked about how they stand outside and they get their sun and boom, they have energy, they have food, right? They also, as the process of them making food, they take in sunlight and they take in CO2. They take both of those things in. When they take both of those things in, then that's the process of photosynthesis. While heterotrophs, we don't do photosynthesis, right? Heterotrophs do not do photosynthesis. We just eat up the plants and take all their sugars and their whatnot and their carbon, okay? So again, autotrophs are going to stand outside. Oh, I am jumping ahead of myself. So autotrophs are standing outside. They take CO2 from the atmosphere, and through the process of photosynthesis, they take the carbon dioxide and they take the sunlight and they make their own sugars. Then heterotrophs, we can't make our own sugars, so we just eat up the plants and get sugars and carbon that way. However, we also do this thing called cellular respiration. Respiration, breathing. Cellular respiration is how both plants and animals release CO2 into the air. So plants do breathe. They breathe, their cells respire into the air. They put CO2 back. Okay, while decomposers, as always, their job is to break down dead organisms, and they recycle that carbon into the air, soil, and ocean. So an example of a microorganism would be fungi, mushrooms, or bacteria. So again, the carbon cycle, what that looks like now is CO2 in the atmosphere. We have plants and we have animals. Plants and animals breathe. They do cellular respiration, so they breathe out CO2. That is a carbon source, right? Because it's going from their bodies out into the atmosphere. That is a carbon source, cellular respiration. All living things do cellular respiration. At the same time, as plant and animals die, then they're put into the soil, and in that soil there are these things called microorganisms, fungi, bacteria, and they're going to break down those bodies and get the carbon that way as well. Okay? Those are two carbon sources. Okay, so in terms of long-term storage, carbon may be stored for long periods of time in the atmosphere, in bodies of very cold oceans, in soil, rocks, fossil fuels, and of course the core of the earth. So again, carbon sources and sinks. Let's talk about those. So carbon source and output, a source of carbon that puts it into the atmosphere, is going to be cellular respiration. And then of course, as we drive our cars, we are burning fossil fuels, aka gas. Then we have what is called a carbon sink. A carbon sink is going to sink the carbon out of the atmosphere and put it into something else. It's going to sink it. And as it sinks it, places that sink it are going to be the ocean, very cold oceans, freezing oceans, and we'll talk about why that is. And of course, photosynthesizing plants, because like I said, to do photosynthesis, plants take sunlight and they take carbon dioxide. They take both of those for photosynthesis. So some words to know, because it's not always going to be the exact same word. Sometimes you'll see carbon source, other times you'll see carbon output or carbon producer. Those things all mean the exact same thing. While carbon sink carbon storage, and carbon reservoir all mean the exact same thing. So make sure that you know if it says reservoir or storage or sink, that you still know what it is, what it's asking you. So let's do some checks for understanding. So would you say this picture right here is a carbon source or sink, and why? Okay, so if you said carbon sink because of photosynthesis, you are correct. There's grass, there are trees, they're going to do photosynthesis. And to do photosynthesis, remember, plants must take in sunlight and they also take in carbon dioxide. They take in both. And then if you said is a carbon source because it does cellular respiration, as all living things do cellular respiration, you're also correct. So they are both sources and sinks. Is this a carbon source or sink, and why? Okay, if you said it is a carbon sink because it is an ocean, you are correct. All oceans are going to be carbon sinks. However, the best oceans that are carbon sinks are going to be colder ones. And the reason why cold oceans are better than warm oceans, listen up. It's going to ask you this on your virtual notebook. The reason why is because colder water is going to have more marine autotrophs, such as plankton, right? They like the cold. So if there are more marine autotrophs and they are doing photosynthesis, then they're taking the sunlight and the CO2. So if I have more autotrophs who are doing that, then I'm going to sink more carbon into it. Okay? So water with more marine autotrophs can take up more carbon dioxide, like I just said. Is this a carbon source or a sink, and why? This is definitely a carbon source because it's burning fossil fuels such as natural gas. So humans have a major impact on the carbon cycle. Fossil fuels are actually considered a non-renewable resource because they are being used up much faster than they can be replaced by nature. So they're non-renewable, and we're just kind of burning them as if they are renewable, and they're not. So normally, the Earth naturally warms and cools over time. So look at this right here. This is over thousands and thousands of years. The Earth gets cooler, then it gets warmer, then it gets cooler, then it gets warmer, cooler, warmer, cooler. And now we're getting warmer as it naturally should do, but we're already way past the point that it naturally should be at. So we are actually speeding up this process by a lot. Now on to our other favorite element, nitrogen. Nitrogen is an essential element that makes up about 78% of Earth's atmosphere. So most people would think that oxygen makes up the whole atmosphere because we breathe oxygen, that's how we survive, but that's not the case. Nitrogen is actually the most of our atmosphere. So, like I said, most of our atmosphere is nitrogen, and in the atmosphere, in the air, it's in the form N2. So it's in its 2 form, N2, atmospheric nitrogen. However, plants need ammonia, which is NH3, in order to do their job, in order to grow. So plants, they look at N2 and they can't use it. They need NH3. So we have this handy dandy thing that's called a nitrogen fixing bacteria. The nitrogen fixing bacteria's job is to live in the plant root and take N2 from the air and turn it into NH3 and give it to the plant. Okay? What type of relationship is that? I know it's a symbiosis relationship, but which one was it? Was it mutualism, parasitism, or commensalism? Which symbiotic relationship was that? It's mutualism. Exactly, it's mutualism. Because nitrogen-fixing bacteria live in plant roots. So they have a place to live, a free place to live. So that is a benefit. They're being benefited, okay? And then we have the plants that are getting NH3 for free, right? They're getting NH3. So that is also a benefit. They're both benefiting. That's mutualism. They are mutualistically related. Okay, this nitrogen fixation and all of that is very important. Okay, you will definitely need to know nitrogen fixation. So how do animals get nitrogen? Well, they get it by eating plants, same as carbon. There's a thing called nitrogen recycling. Again, it is the same as carbon recycling. As organisms die, they're broken down by decomposers in the soil, and then that nitrogen gets to go back into the soil, and then that process of nitrogen fixation can happen again. So again, like I said, plants and animals die. When they die, break down into the soil, microorganisms break them down, decomposers break them down, and that nitrogen is now free to be used by nitrogen-fixing bacteria and plants. So what happens if something goes wrong with the cycle? What happens if something goes wrong with the cycle? So there are many ways for this carbon cycle to be disrupted. So by burning fossil fuels, like in cars and factories, we are putting a lot of CO2 into the air, and there's no way for it all to be sunk. So yeah, that's disrupting the carbon cycle. By killing off trees and other photosynthesizing plants, again, we're removing a sink, which means there's less carbon being sunk, which means there's more carbon in the atmosphere, which means that it's getting hotter and warmer and bad. We also have what's called urbanization, the building of cities, having cars. There's just less space for plants, and there's just more cars that have been putting out more of that damaging CO2. And then, of course, we have ocean warming. As the oceans are getting warmer and warmer, then they are killing off those autotrophs, those plankton. And if we don't have as much plankton and autotrophs in the water, then they are not taking in carbon. So again, that's disrupting the cycle. So, like I said, if there's like a forest and every single one of these trees is doing photosynthesis, they are taking in sunlight and they're taking in carbon dioxide to do photosynthesis. However, if part of it gets cut or burned or slashed or diseased or whatever, then now we have way less that are taking in sunlight and carbon dioxide, which means that carbon dioxide that normally is being taken is not being taken, it's being left in the atmosphere. Then this is urban sprawl, what it looks like. Trees are being cut down to make space for giant buildings and houses and things. We also have trash that is polluting the river. There's lots of fertilizer runoff, all kinds of things that kind of disrupt the carbon cycle in a number of ways. So if you remove any of these things, dead organisms, if you remove less ocean water, if there are less plants, less marine autotrophs like plankton, less rocks and volcanoes, or if we remove fossil fuels from the ground, then we're going to increase carbon. We're going to increase carbon by doing those. And if you're not sure how that is, pause the video and think about that for a second. Go through each one and think, okay, I got it. Now the nitrogen cycle can be disrupted. By burning fossil fuels, it's going to increase the amount of N2 in air, right? There's also this thing that's called acid rain. If you've ever wondered what acid rain is, it's literally when there's too much nitrogen in the rain, in the water. And that is when it burns and it rains. It rains and it burns and it damages things, and it just makes it very hard to live in that area. Okay, and then with the misuse of fertilizer. So like we said, with nitrogen-fixing bacteria, their job is to give NH3 to plants. However, you can fake that process by just giving plants NH3 in a fertilizer. However, fertilizer chemicals can very easily get mixed in with regular drinking water of either humans or animals or even plants. And when that happens and there's decreased oxygen in marine ecosystems, and that, like we know, is very bad, that kills lots of fish, it kills lots of little organisms like plankton. Just a quick recap of what we learned today. The importance of the carbon cycle. So plants take carbon from the air when they photosynthesize. Plants and animals put carbon into the air during cellular respiration. And microorganisms in the soil break down dead material, dead plants, dead animals, and release carbon into the soil. The importance of the nitrogen cycle. Nitrogen-fixing bacteria are going to live in plant roots, and they're going to convert atmospheric nitrogen into ammonia and give it to the plants. Microorganisms in the soil break down dead plants and animals and release nitrogen. And then, of course, disruptions to these cycles. So human activity are actually increasing CO2 in the atmosphere more than ever. And Earth's natural heating and cooling is kind of disrupted, not even kind of, is very disrupted by this excess CO2 in the atmosphere. Also, nitrogen fertilizer runoff into oceans is literally killing marine ecosystems such as fish, such as plankton, kelp, algae, all of those are being killed. Okay, last but not least, your Unit 1 test is coming up. It'll be over all the topics we've talked about: levels of organization, symbiosis, succession, food chains and food webs, and then carbon and nitrogen cycle. And then we have 2 more topics to talk about later on this upcoming week. So please make sure that you're studying and taking good notes on your own. I have a little notebook and I write down things as I am planning out lessons, and you should be writing things as you're viewing the lessons so that you can review them. Also reach out if you need any help with that. I recommend studying starting today. Okay, study that old material, look back at your virtual notebook, look back at your exit tickets, and try and do your best.